First of all, I would like to introduce Professor Ivanov. Professor Ivanov holds a PhD in Industrial Engineering and Production Management. He is Professor of Supply Chain and Operations Management at Berlin School of Economics and Law. His research records includes over 370 publications with over 110 papers in prestigious academic journals. He is editor of International Journal of Integrated Supply Management and an associate editor in International Journal of Production Research, International Transactions in Operational Research, and International Journal of System Science. Dr. Ivanov is profiled in supply chain and operations management, operations research, and industrial engineering. So, Professor Ivanov, you are welcome to start your presentation. Thank you.
Thank you, Hani, for your kind introduction. Hello, everyone. Good morning, and welcome to my talk. Today, I'm going to talk about trends in digital supply chains. So I suggest that I start. So actually, I combined this presentation from different plenary talks, which I recently gave at Informs, IFAC, POM, Decision Science conferences. So it is voice over slides. It's a kind of a recorded video. And the objective is that while you are watching the video, please feel free to ask questions in chat so that in parallel I can communicate with you. And after that, after the talk, we can, of course, discuss all your questions live. And since different slides are coming from different presentations, don't be confused that maybe sound quality will differ across different slides. Anyway, so hope you will enjoy it. Hello everyone, and welcome to my presentation on digital supply chain twins. Our major topic today is digital supply chain twins. And so let us start a discussion with defining a digital supply chain, right? For the last years, supply chains have been experiencing technological transformations on the scale unlike anything before. Industry 4.0, additive manufacturing, sensors, collaborative robots, cobots, visibility systems, and blockchain render principally new business models and data utilization opportunities, which entails highly flexible and adaptable supply networks characterized by structural variety and multifunctional processes. And these novel settings of cyber-physical nature pose new chances, but also challenges for management decision-making support, which obviously go beyond classical optimization and simulation techniques toward technology and data-driven complex decision support systems. Let us start with the definition of digital supply chain. Currently, there is no unique definition and no unique understanding of what is a digital supply chain. That's why I would like to propose two possible perspectives on the digital supply chain. The first perspective is a broad view of a digital supply chain, where a real supply chain with advanced utilization of digital technology like Industry 4.0, additive manufacturing, robotics and automation, and end-to-end visibility, it's considered as a digital supply chain. So digital supply chain is a kind of a cyber-physical network of digitally connected, coordinated, and integrated organizations, technological equipment, and data-driven algorithms with dynamically adaptable material information and financial flows, and capable of real-time reacting to changes in demand and supply through rapid rearrangement and reallocation of its components and capabilities. And the second view is so-called narrow view, where we understand only a digital part of the supply chain as a digital supply chain. So here we could say digital supply chain is a cyber network of end-to-end visibility representing a physical supply chain with some associated operational data and performance assessments. Technologies for end-to-end visibility are multiple and include digital supply chain collaboration platforms, big data analytics, artificial intelligence, for description, prediction, and prescriptions of actions in supply chain. Then we have blockchain and track and trace technology, for monitoring and tracking on supply chains. And finally, we should think of early warning systems for timely detection of possible events in the supply chain. Well, the ideas of combination of physical and digital parts of the supply chain finds its practical application in digital twins. Digital supply chain twins, computerized models in real time. Digital supply chain models that at each point of time represents a physical supply chain with the actual transportation, inventory, demand, and capacity data. Such a system is of high value for both planning and real-time control decisions. Let me illustrate some aspects related to digital supply chain twins using example of supply chain resilience. Supply chain resilience, especially at the times of pandemic, became very important, and we have observed that companies with end-to-end visibility and digital twins have much more additional capabilities to cope with the pandemic and support decision making. And I will exemplify the next parts using anyLogistix as a supply chain simulation and optimization software, which can be used for building supply chain digital twins. Data analytics is the primary driver of a digital twin. Data analytics is used at the proactive stage for building realistic disruption scenarios based on some risk data about historical disruptions and other data like weather data, financial data, supplier reliability data, which can be obtained from ERP systems, for example. At the reactive stage, data analytics can be used for disruption identification and in real time using some feedback data from sensors, stress and tracking systems, and RFID. And then this data is transferred to simulation and optimization model, which through computations, which we already discussed previously, can allow analyzing of performance, which can then be transferred to business intelligence or ERP systems. Combination of simulation, optimization, and data analytics constitutes, therefore, a full stack of technologies to create a digital supply chain twin to improve resilience, a model that always represents the state of the network in real time. Well, so anyLogistix can be considered as a digital supply chain twin. Digital supply chain twin encompasses three major perspectives: a network, flows, and parameters. Right? So the supply chain network can be designed using different location objects in anyLogistix, such as customers, distribution centers, factory locations, and supply locations. So we define structure of our supply chain, right? So in other words, if you look in the middle of this picture, we define firms involved in our physical supply chain. Next, we should define flows, right? The flows in the network can be flexibly arranged to represent specifics of different supply chains. The flows are associated with some design capacities. Design capacity means a maximum capacity in production, in warehouses, in transportations, and these flows should be controlled, right? And in any logistics, they are controlled by associated production, inventory, sourcing, and shipment control policies. Now, there are also very specific control policies, for example, backlogging rules or sales batches or any specific payment terms. These control policies can be flexibly adapted to the specifics of any particular supply chain and its management rules. And finally, different operational parameters such as demand, lead time, and control policies, thresholds like reorder point, target inventory, or minimum vehicle load can be defined. And with that functionality, a digital model of a physical supply chain, so we can say digital supply chain, can be created and used for optimization and simulations to analyze performance of supply chain operations, customer performance, financial performance, and also to analyze dynamics of supply chain operations and performance under business as usual scenarios or under specific disruption scenarios, right, which can be defined as events, for example, stochastic events, subject to some disruption duration and recovery time. We now illustrate principles and data-driven disruption modeling on example of a digital supply chain tool developed with the use of anyLogistix software, which is a tool for model-based decision-making support in supply chains. A combination of simulation and optimization and data analytics is based on the mapping of risk data with geographical location in the supply chain structure. On one hand, we have disruption data coming from different digital sources, data about different disruptions. This data can be retrospective, which can be used for statistical analysis about previous disruption, and this data can also be real-time data, which is obtained through monitoring of supply chains. Disruption data is transferred to simulation and optimization models. In between, filtering of data happens using big data analytics and machine learning techniques. And then the disruptions are put into simulation models like disruptive events. If we use event simulation, discrete event simulation, all this data it's transferred to the constraint system of mixed integer linear programming models. And with this data, simulation optimizations models can compute optimal proactive resilient supply chain designs and also reactive recovery plan. As such, the retrospective data it's mostly used for prediction and analysis of possible disruptive scenarios, while real-time data is used for real-time control and deployment of reactive recovery planning. The results of the modeling it's transferred to ERP systems or BI tools for further extended performance analysis. Finally, if we generalize the insights from this case study, digital supply chain twins like anyLogistix are of utmost importance and value for stress testing and reviewing supply chain resilience, right? So one can certainly look at creating some scenario, like COVID-19 pandemic or Suez Canal congestion in the supply chain, or any other short-term or long-term disruption scenarios. And then with the help of supply chain model, one can make a kind of stress testing of the existing supply chain, look at possible performance impact through simulations, and also consider analyze possible reaction recovery plans and select the most efficient, the most responsive one in terms of operations and operations performance, customer performance, and financial performance. So basically, digital twins are an ideal tool for stress testing and reviewing supply chain resilience. We now conceptualize a generalized framework of digital risk resilience analytics systems in the supply chain, which we can see in this slide. Going from the bottom up, we start analysis with understanding a supply chain as a cyber-physical system. The firms in the physical supply chain and the information technology generate data about sourcing, manufacturing, and logistics in forming a cyberspace of the supply chain. And this data can be used for risk analysis and prediction. Supply chain model serves in this setting to integrate a physical and cyber component, and it's considered to be a central element in the resilience analytics systems, aiming to integrate physical and cyber components within a simulation and optimization engine of a digital twin. As such, the generalized framework for supply chain resilience management can be viewed as a cyber-physical system that integrates real physical processes and virtual computational services. In other words, the digital twin of the physical supply chain exists in the cyberspace in the form of cyber service chain. Combination of simulation and optimization with data analytics and performance evaluation systems constitutes a new level of digital technology that allows experimenting with different supply chain disruptions and resilience strategies, test different what-if scenarios, and quantify the effects of these changes. In this setting, the cyber part of the model represents data about the supply chains, a digital supply chain with real-time transportation, inventory, demand, and capacity data. For example, if there is a strike at an international logistics hub, this disruption can be identified by risk data monitoring tool and transmitted to simulation model as a disruptive event. With this, simulation will support forecasting of disruption propagation and quantification of its impact. And on the other hand, the simulation optimization engine can provide efficient recovery policy, testing different deployments of contingency plans according to actual situation. For example, it can be recommended to reroute material flows using some backup facilities. And as such, resilience risk analytics systems can be used at pre-disruption stage, during the disruption, and post-disruption mode when we are recovering. At each of these three stages, pre-disruption, disruption, and post-disruption, data analytics systems can help in the areas of analysis, modeling, control, and learning. Right? In the area of analysis, we mostly talk about descriptive and diagnostic analysis, which can help understand us disruption impacts in the past. Then we can talk about predictive simulation and optimization in the modeling area, when we try to predict the impact of different disruption scenarios on performance. And after that, we can look at the prescriptive level of analytics using real-time data for disruption identification and prescribing actions, recovery policies through risk mitigation learning, disruption recovery learning, and disruption pattern recognition. Another important area is viable supply chain. Supply chain viability is seen as the next direction, next step in resilience theory development. And the importance of this part of this area became evident through the COVID-19 pandemic times. So viability is seen as the ability of a supply chain to maintain itself and survive in a changing environment through a redesign of structures and replanning of performance. So a viable supply chain model is based on adaptable structural supply chain designs for supply-demand allocations and, most important, establishment of adaptive mechanisms for transition between different supply chain designs. Usually, before the pandemic, the companies have mostly focused on efficient or responsive supply chain design, right? And considered, for example, random uncertainty like demand fluctuation as a possible stressors to this design. Many companies have also utilized resilient supply chain designs as a response to natural disasters, for example, which considered some, resilience capabilities like risk inventory or capacity buffers or backup supplies. However, one element was missing, and this element became very evident through the pandemic, and this is survivable supply chain design. Through the pandemic, we have observed that the firms needed to repurpose their supply chain, to redesign supply base and logistics, to localize many processes. This level of survivability, it's something which became evident for the pandemic time, and now with all these three levels, agile, resilient, and survivable supply chain design, we can define a new kind of supply chain understanding, which is a viable supply chain model, which allows to survive, which allows to maintain operations continuity with regard to different stressors. Random stressors like demand fluctuations, and very severe, very deep uncertainty like natural disasters and even global pandemics, right? So that's more important to survive, to maintain business. And in order to maintain business, we need to ensure survivability of our supply chains. So this is something new which came from the pandemic times and which can be seen as a So very close issue is to viability, it's intertwined supply network. Now, only a few cases supply chains can be clearly separated from each other. They are usually intersecting. Firms can change their behaviors, their roles, buyers and suppliers. The firms can be buyers and suppliers at the same time. And as such, if we look at the intertwined supply network as object of optimization, it makes sense to develop ecosystem view of the supply chain, right? For example, suppliers in automotive sector can be at the same time producers of valves for respirators, All right, so you have two intertwined supply networks where the same firm changes behaviors. So that's why I encourage to look at intertwined supply networks as an object for supply chain resilience management dynamics, right? And to finalize this discussion, another newly emerged framework is the reconfigurable supply chain, which looks at advanced utilization of digital technologies, sustainability, resilience, and efficiency in designing and managing the supply chain network. Right. So reconfigurability is an important part of supply chain viability. Thank you very much, dear colleagues, for your attention. Now I look forward to discussing with you questions about this topic.
Thank you very much, Professor Ivanov, for the very nice presentation. And it's time for the questions. And anyone who wants to ask questions like in person, I can unmute and you can also ask your question. Just raise your hand and till I see. Okay, before I have a couple of questions. In one of the questions in the chat, you answered only a few firms have really curated digital supply chains. For example, a company has a fully implemented ERP system and they have a paperless system. So can we call it that they have a fully digitalized supply chain?
Yeah, that's a great question indeed. When we talk about digitalization of supply chains, right? So we usually consider a network of enterprises, right? So of course, many companies individually have created a kind of ERP systems which help them, to manage their processes on the everyday basis, and also maybe to support some strategic and tactical decisions as well. However, if you look at the network level, the situation becomes different, right? So in observing practical examples, and I've been involved in several large-scale projects on digitalization of supply chains. My impression and experience from this project is that only a few corporations and really high-level technological corporations have achieved certain degree of visibility in their networks. And visibility, end-to-end visibility, it's a precondition of digital supply chain. Right? So if you look at this example, so mostly visibility has been created in the upstream part of the network, right? Where you have in the downstream part, where you have more or less a centralized structure where you can get data from logistic service providers. However, if you look at the upstream part, you find completely different situation. You have decentralized structure. You don't have this central entity like 3PL or 4PL provider downstream, which can coordinate suppliers across different stages, across different tiers in the supply chain, right? So, well, you can have some visibility with the first tier supplier. However, visibility across next tiers in the network becomes more difficult. So that's why the current state is that most of companies have understood, especially through the pandemic, the value of digitalization and end-to-end visibility. And this is still ongoing process, which has multiple dimensions, right? Organizational dimension, management dimension, technology dimension. So a lot of opportunities for research in this area.
Yeah, that's right. In this pandemic, everybody, I think, realized that digitalization, how much it can be important. And we have one question in chat. What is the effect of over-urbanization in digitalization of supply chain and ultimately economy?
Yes, again, the question is certainly great. As the first question, it touches micro level, right? So, micro level, of course, it's really important, and one can expect correlations between digitalization of supply chains and economic developments, right? So however, this is something which we can only speculate about, right? So we can just forecast what could happen with the economy if all supply chains are digitalized. That's why I would say let us focus on the micro level first to understand how, to understand network effects from the digitalization of supply chains. And after that, after sufficient amount of supply chains have achieved maturity degree in the digital supply chain, after that we can start analyzing macroeconomic impacts of all this stuff.
Thank you. And we have two more questions in chat. Nassim asked, what would be the effect of digitalization, digital supply chain on mobility in transition?
Yeah. So, of course, so the topic of conference today is mobility, right? So that's why everyone it's interesting. Of course, Faculty of Transportation, and so on. Certainly, there will be many effects of digital supply chain on mobility transition, right? You can so if you look at state of the art, right? So in global supply chains, you have some or many companies have end-to-end visibility, say until international harbors, international ports, right? But I am not aware of any successful implementations where we have, say, last mile visibility in the supply chain, right? Because of so complex organizational structures, first of all, right? So you can, with the help of 3PL service providers, you can achieve some visibility across different countries until the last large international hub. But then if you look in the last mile deliveries, here it is still a research gap how to achieve visibility in this area. Certainly there will be many effects at different levels, at the network level, at the transportation planning levels, and also last mile delivery logistics.
Thank you. And second question from Nassim is that okay, we are using different technologies in digital supply chain, and what technology disruptions deserve immediate and more attention?
Yes, that's a fantastic question. Indeed, we have now a lot of technologies, like blockchain, like Industry 4.0. Well, Industry 4.0 is not exactly technology, right? It is a combination of technology, management, and organizational works. Still, so you have automation technology, we have robotics technologies, we have sensor smart products. We still have RFID, right, which also makes sense. So, and the issue, we have data analytics technology, machine learning, all this stuff. The question is, first of all, how consistent is this technological block, right? Sometimes I discuss with researchers and with managers about blockchain, right? And so sometimes I'm thinking, what is the difference between a blockchain and distributed open database, right? So maybe these functions which are covered by blockchain already exist in the supply chain. That's why we should create a clear picture of how different technology help us in different areas of supply chain management, of transportation, of logistics, of mobility, right? So otherwise it can happen that we have many technologies which actually do the same thing, right? And this is something what we should avoid, try to avoid this redundancy and use technology very efficiently. That's why, so this digital twin, blockchain, Industry 4.0, this is something which deserves immediate attention individually and also in combination,
Thank you. And Professor Schegner asked the question, will the digitalization of supply chain always positively influence the resilience of the overall system?
Yeah, that's a fantastic question. So the issue is now, so how much digital and how much end-to-end visibility do you need to manage resilience, right? Of course, it is unrealistic to achieve 100% digitalization and 100% end-to-end visibility of the whole supply chain. Maybe it's possible, but the cost of this digitalization and visibility will explode, right? So that's why so far my understanding is that we should focus on most critical components of the supply chains, critical in terms of revenue, critical in terms of return on investment, critical in terms of customer satisfaction, right? We should focus on most critical products, most critical suppliers, most critical production lines in the network, and think about their resilience, right? And investment in digitalization, because it's always a question of investments and returns. How much should we invest in digitalization? And what is the value of this investment? How can we increase resilience by that, right? Certainly, as we have seen through the COVID-19 pandemic, companies with a high degree of digitalization could survive better as compared to the companies without digitalization, especially at the beginning of the pandemic, when supply chains became really chaotic. The data visibility played a crucial role to understand who is working, who is available, which transportation connections are available in the network, what is broken, right? So this is something where resilience, where digitalization can really add value to resilience management.
Thank you. And Mary asked the question, can you please throw some light on adaptation strategy that has uniquely impacted the vaccination supply chain in extreme weather zones?
Oh, that's a so great question. It combines three major topics: climate risk, or say climate change risk, then pandemics, and supply chain adaptations. So far, I think we yet to understand what happened with vaccine supply chains, because not too much data about this issue. Right? So that's why adaptation strategies, if you look generally at adaptation strategies for the pandemic, we can see four major strategies. I recently published a paper on 4 major adaptation strategies in IGPR. The first strategy is scalability. The second strategy is substitution, right? The third strategy is repurposing, right? And the fourth strategy is intertwining. Scalability means supply chain can expand capacities, like Amazon did, for example, when demand for online, for e-commerce has increased. Substitution means we can substitute production of one product by another one. Similar with repurposing, but it looks at manufacturing, when companies which usually produce, say, cars or some perfumes, repurpose their manufacturing to, say, some face shields or masks or something related to pandemic. And intertwining means that commercial and healthcare supply chains can share their capacities, which is actually also something related to the pandemic. And then we look at extreme weather conditions. This is something which we can think about for future, because there are some forecasts that many regions in the world will not be available for manufacturing and logistics activities in the next 20, 30 years, right? And this is the question: how should we redesign our supply chains when, say, a region where currently we have 50% of global capacities will not be available for 2-3 months? What are best adaptation strategies to continue using these regions, maybe building up inventory in expectations of long interruptions, or move facilities from this region to more geographically safe regions where we cannot expect severe weather. And in Germany, last week we have seen severe weather condition, and it's also connected to pandemic, right? Because virus it's now starting spreading in these regions, and urgently the vaccines are urgently needed in this region. So it's a great question that combines so many dimensions.
Thank you very much. Professor Buscher also asked the question. Thank you for your interesting talk. Can you give us some ideas about the interplay of simulation and optimization? Which models are used? How can we correctly integrate machine learning? I think his question is mainly about we have classic optimization methods and we have machine learning is like hot topic now. How can we integrate these two?
That's a fantastic question, and thank you, Professor Buscher, for this. First of all, let us start with differentiating, say, digital twins and simulation and optimization models. Right? So, digital twin, digital supply chain, it's something which is different from simulation and optimization in several aspects. I would say three major aspects: complexity, integration, and decision-making support. Digital twin is much more complex, right? It covers all areas of network, of supply chain, and not only some fragments like simulation and optimization models usually do. It is about complexity, then about integration, right? So digital twins, of course, contain simulation and optimization models for facility location planning, for inventory control, for recovery in case of disruptions, right? However, they are integrated with external systems like weather systems, early warning systems, systems. So a lot of blockchain, RFID, and so our simulation and optimization models and digital twins become, I would say, alive, right? From offline modeling to online modeling. They are always fed by data, real-time data from systems. This is a kind of integration. So we have model which always work with real-time data. And every time when we start optimization or simulation, it works with updated data. And then decision-making support, right? Simulation optimization model usually delivers us some numerical output, right? And digital twins, it's a little bit more. It is not only about having some numerical output. It's about possibility to compare different alternatives, to compare different action plans, to compare performance of different suppliers, for example, to select most efficient recovery strategies, to analyze alternatives, right? So that's why I would say this is something where how simulation optimization, of course, simulation optimization, it's main component of digital twins. Digital twins is a little bit more. And machine learning, I mean, there are so many applications, right? So we know how, for example, we can improve inventory management and demand forecasting by learning demand and sales data, right? This is one application. In our resilience modeling, we combined machine learning and simulation, where machine learning is used for analyzing outputs of simulation and optimization models, right? And it's a kind of feedback system, right? So we analyze outputs, then we put this filtered output again as input into the model, and this filtering and feedback control, it's organized by machine learning. So, for example, so it's a great question. I could talk a lot about that. However, I know that the next speaker is it's already waiting. Thanks a lot for all these great questions and discussion, and for inviting me today.
Thank you very much. Unfortunately, we have 3 questions left, including Professor Urba's question. I will appreciate it if you could answer this
Yes,
question in
yes,
chat.
of course.
And we can start the section with Professor Bektaş. Thank you very much for your presentation. And I'm sorry, guys, that I couldn't cover all the questions in this time. And